Hey everybody, we're going to go over some of the solutions now from that problem set. And hopefully we can clarify some of these a little bit more. So let's start with the first one. A triangle is in the shape of a 30, 60, 90 right triangle. If the hypotenuse of the outer triangle is 45 feet, find the lengths of the triangle in inches. So be careful, right? The big thing here is that we're given something in feet and we need to do something in inches, right? So there'll be a conversion factor of some sort playing out here. So what I did was I drew out the original basic problem, okay? Just drew it out as it was. So I just took what was there and drew it out. Labeled it with the 45. So I used the 30, 60, 90 special right triangle. The expressions locate the side of the given triangle to solve the problem. Well, that's a very oversimplified way to say, look at this and make sure we understand what we're saying. Notice that these triangles are exactly the same, okay? They're exactly the same. They overlap on top of each other, right? The only side that we know anything about is 2s. We know it has a value of 45. You see? See how 2s, boop, right on top of that, 45? So what we're saying here is that once you have the problem that's a 30, 60, 90, immediately draw that beast out, okay? And that's the relationship for the 30, 60, 90. So the expressions, remember, are always like this, right? Opposite the 30 is S, opposite the 90 is 2S, and then what's ever left over, so to speak, we'll put it like this maybe, is S root 3, okay? So we want to label it in a fashion maybe like hypotenuse if you want, that's fine. 2 opposite and 3 adjacent, just like we've been doing in our past, okay? So what we did was we then set 2s equal to 45 and solved, right? So all we had to do was divide both sides by 2. Okay. Then we use dimensional analysis, or what you might have heard before, unit conversion. Depending on if you were in a chemistry class, you might have heard dimensional analysis, but if you haven't, you probably might have heard unit conversion. And that's all I did here was I took the 45 halves feet, right? And then I multiplied it by a conversion factor. Well, what did I do? I put something special in, right? We knew it was feet, so I'm playing the match game. So see how I have feet in the numerator? Notice there's no denominator. There's just feet, right? With nothing underneath it. Technically there's a 1, but it looks like there's nothing underneath. So that's in the numerator. So the other feet, right, is in the denominator. So those two will eventually make a factor of 1. And in that case, we can now take 12 divided by 2, and I'm hoping that's where you see I got the 6. So every 245s is a 90, so hopefully you see where I got the 270, okay? So now that we know what the side is for S, right, that's one of the ones that we want, because if we know S, then all we have to do is substitute, okay? So now all we're saying down here is substitute the value of S back into the missing sides of the right triangle expressions. So that's exactly what I did. Since S was 270, I just took that and I took the smaller side right here, S, and that became 270. I then took the other side, substituted S, and then came up with the longer side. And the question asked to make sure of what? That they were in inches, right? And we've already done that. In fact, I forgot to actually label something. I just didn't have enough room, I think, but this is also in inches, right? So our question says, simplify your answers, type an integer or a simplified fraction. Type exact answers. Okay, remember, exact answers are not in the calculator. Not in the calculator. It is not a calculator. The calculator is always an approximate solution. So we do have our two solutions, and we do have the correct units. So that's good. All right. Now, let's move on to the next problem. Now, this is where I'm trying to get you guys to look at a word problem and really start to visualize it. So I'm going to start calling the image an imagination, right? Because image, imagination. Okay, so a hot air balloon. So we have a hot air balloon flying at an altitude of 2997 feet. Ooh, that was cool. If the angle of depression from the pilot in the balloon to the house on the ground below is 27 degrees from the pilot. So how far is this house? Well, how do we find out how far this house is? Well, we draw an imagination picture. We visualize it in our head, what the problem is saying, and then we try to make a picture out of it. So I drew a little house right here, and possibly I should have drawn the house maybe actually to be up here, but not drawn to scale. So now I know that I have a hot air balloon and I have a house, right? That's what the two things said that we have. We have a hot air balloon and we have a house. So I drew those two out, and then I put in the line where the person could see from the balloon all the way down to the base of the house or on the ground, right? So now that we have a base image of what we want to work with, we now can really put together a better triangle, in other words. So what we're going to do is, like I said, we're going to call this the imagination. So redraw the imagination image using information from the problem. And we know the angle of depression, and we know the altitude of the object. So I drew them in. The angle of depression, remember, here's the horizontal, right? So we always swing down, and that will give us an angle of depression. So I did it in a little bit of a dashed ray here so that you could see the angle of depression. Now, I then put in what? The altitude. And then I let some variable be d. And notice this time in the notes, I didn't tell you, I should say, let d be the what? Distance from hot air balloon to base of house, right? We should make some good statement there, right? So now we know that d is that distance. So from that, we're now going to create a quadrilateral and solve for the unknown d. So you can see what I did here. I used the same color coordinations that we've been doing in our past videos, where the hypotenuse is red, and we can tell that from right here, right? So if this is the right angle from here as well, then opposite the right angle is D. That's the hypotenuse. We know opposite is 2,997 feet. It's opposite the angle 27 degrees. Okay. And that's all we really need to know. We know that we have an opposite and we have a what? Hypotenuse, right? Those are the things we're working with. So if we're dealing with the hypotenuse and an opposite side, then we're clearly not dealing with the cosine, and we're clearly not dealing with the tangent, we're dealing with the sine. So notice what I did. I used the sine and did a substitution. I substituted the numbers in. 27 degrees, the angle of depression, is equal to the opposite, right, over what? The hypotenuse. Then I did symbolic manipulation to just solve. So on both sides, I multiplied by d and I divided by sine 27. And when I run that through the calculator, I get 6,601.5 feet. So the distance that the pilot can actually see to the base of the house is 6,601.5 feet, or half foot. And I think it was to the 10th place, if I remember correctly. Yeah, round to the nearest 10th. So the idea here is you could have also have done what? You could have figured out this angle right here, right? I'll just call it theta. And then you could have used something else, right? Would you have used the sine or the cosine if you were to use theta? Yeah, that's right, you'd use the cosine. So if you do it on your own and you try it, you should come up with the same exact number that I do here. Okay? So try it out. All right. The next one, I drew out the imagination problem for the skateboard ramp, right? So we have a ramp, and it's 20 inches high, and it rises at an angle of 23 degrees. So I drew that basic image out right here, right? I drew out some kind of picture that would make sense. And I said, okay, well, here's the ground. Okay, well, there's a part of the ground that I want. That's going to be called the base. And I know that the ramp has got a height to it, because that's always a slope, right? And that's the incline that's raised 23 degrees. Notice the arrow from the horizontal. It's rotating, okay? So after I did that, I then decided to look at just a basic right triangle with just the essential information put into it. Now, I obviously didn't make the statement here either, but what could we say? We should or could say let B be the base of the ramp. You okay? So now we've defined our variable. That's more of an algebra concept, but we've defined our variable, and now we're going to solve. And clearly we have to use tangent here. Why? Because we have the opposite and the adjacent. Well, how did I know that? How did anybody know that? How do we all know that? Well, remember how we label the right triangle. Opposite the right is always the height. Opposite the right is always the height. Opposite the right is always the height. Height, height, height. So, label that one first. Okay? The next one is always looking at the angle in question. That's the 23. Look straight across. Look right across from that angle. That will be the opposite side. And then the last is always going to be the adjacent, whatever side of the triangle it is. Okay? So we clearly are using tangent. So I did the substitution, and then I did the solve, right? And all I did was what? If you look very carefully, I'm just changing the spots, right? I'm dividing by b on the right, so now I'm multiplying by b on the left. I'm multiplying by tangent 23 on the left, so now I'm dividing it on the right. Remember, opposite sides are opposite operations, especially when these are nice, simple solutions to make like this. Okay? So, when I ran that through the calculator and rounded it to the inches, just the ones place, I got 41 inches. So I just plugged that into the calculator to get my approximation, and it said out to the nearest inch. Okay, so hopefully that helps. This is going a little quick, remember, as well, because time is always of an essence here. So next problem. The walkway forms one diagonal square playground, okay? So I drew my playground out. It was a basic image, and I just a square with a diagonal. And you could have gone right for, break it down into, your image and substitute the known value, if you so please. But if you draw something out like this, that gives me an idea of where you're going. Do you need all of it? No, but a good place to start and a good place to end are always good pieces of information to have. So I broke down the square. I labeled the walkway gray, and I put the actual value for it, 28 meters in. We know it's a square, so all the sides are congruent and all the vertices are right angles. So since we are bisecting a right angle, we just take 90 degrees, divide it by 2, and we know we have 45. The minute you see 45 in a triangle with a right angle, you want to think 45, 45, 90. Woohoo! The minute you think that, you want to think this. Okay? That relationship is the one that's going to save you with all of the types of problems relating with the 45, 45, 90. So what I did here was I drew both of the triangles out. I drew one in black, the regular problem that we had, and I drew the other one out in red, which I already signified over here. So all I'm going to do again is I'm going to take this special right triangle and just shift it over so that we can clearly see, boom, that S root 2 is the same as 28 meters, or 28 meters is the same as S root 2. The expression S square root of 2 is then equal to 28. So I'll put this back over here somewhere. Okay? And now we want to locate the sides that are the same and solve, right? So now we know that 28 is equal to S root 2. And that's what I'm trying to say down here, right? The hypotenuse of the left triangle is equal to the hypotenuse of the right triangle. So that was 28 equals S root 2. You are then going to divide both sides by square root of 2. And then you're going to do what? Do you know what I did here? Starts with an R. I'll write this one down. Did you get it? Oh, good. Rationalize the denominator. So because we had square root of 2, we just multiply by the square root of 2. At this stage, that's all we need to know. There's a lot more to it than this, but at this stage, that's all we need to know. And when we do that out, if you don't see this, let me do this in blue over here. This will be 28 root 2 all over 2, but you could still take 28 and divide it by 2, and that's where I got the 14 root 2. You guys okay? And then it said round to the nearest, what was it? Round to the nearest meter. So I rounded it to the nearest meter, about 20 meters. So that's the side of a sorry, that's the side of our playground. So hopefully that clears things up a little bit. I'm trying to get you to read the math here. Okay. And guess what? We're almost there. Here we go. This one's a nice one. It's actually straightforward because we got and have this picture, right? We have this wonderful picture. A road is inclined at an angle of 6 degrees. After driving 4,553 feet along this road, find the driver's increase in altitude. Okay, so not a big deal. Well, we'll start with the given triangle because they gave it to us. Why not use it, right? So I just rewrote it and put everything down. Okay. I then labeled the sides and used SOHCAHTOA to find A. So, why did I pick sine? Well, remember, we're dealing with this angle here, right, which is 6 degrees. So, if I labeled the sides of the triangle correctly, I'm going to label this side first as the height. Then I'm going to look again, right, at this 6 degrees, right? And then I'm going to look across from that, label this as opposite, and then I don't really need to know the other one, but it is the adjacent side in this case. So the only one of the trig ratios that deal with opposite and hypotenuse is the sine, right? Because the sine is the opposite over the height. So I just did my substitution, and then I multiplied both sides by 4,553. Plugged it into the calculator and did the rounding. Came up with 476 feet. Okay? So, I'm hoping that helped out a lot. I'm not entirely sure, but leave a feedback comment in the in the comment section below. So see if the interpretation of the problems helps here. There's some difficulties with maybe some algebra or some maybe rounding error that may have happened, but I'm hoping that this did help you guys look at all of the different ways to actually solve these, because there's actually other ways too. All right, well, hope this helped. I'm going to cut it short now, and have a great day. Bye!